Hello, everybody. So today, let me just wrap up this set of slides. Um, so at the end of Lecture 7, Abstract Classes and Interfaces, we have a topic that may seem a little unrelated at first. It's about processing primitive data type values as objects. So if you remember, primitive data types were basically Boolean, character, short, byte, integers, long, float, and double. So these are the primitive data types available to us in Java. Uh, but we can also use these inside of classes, inside of wrapper classes, we call them. So the names of these classes are very similar, but not exactly the same as that of the primitive data type. So for example, Boolean, it's still called Boolean, but Boolean for the wrapper classes with a capital B. uh, char for the character as a primitive data type becomes the name of its wrapper class is character with a capital C. So as a rule, all class names over here begin with capital letters. Otherwise, short remains short, byte remains byte, int becomes integer, the complete word. Long becomes long, float remains float, double remains double. But like I said, the first letters of all of these class names are capitalized. So today we're basically going to look at these wrapper classes. Remember now, these primitive data types are something else, and wrapper classes are just classes. Now, why is this topic included in this specific set of slides where we are talking about abstract classes and interfaces? And the answer is this. So these wrapper classes, double float, long, integer, short, byte, these are all subclasses of an abstract class called number. This is all part of the Java API. And number is a subclass of object. Character and Boolean are wrapper classes of data types that do not store numbers, and so these are separate. These are not subclasses of number, as you can see. These are direct subclasses of object. So, besides number being an abstract class, another thing that's happening is that we have an interface called comparable. And comparable is implemented by um, all the subclasses of number, double, float, long, integer, short, byte, as well as character. Okay, so you can see that these wrapper classes, you can see the relationship between them. There are abstract classes. There's an abstract class that we're using, and there's also an interface, the comparable interface over here. And that's basically why this topic is at the place where it is after we have studied abstract classes and after we've talked about interfaces. Okay, so um, what's the big deal? Why have these wrapper classes at all? Well, there's some interesting stuff you can do with them that the primitive data types don't allow you to do. So, for example, uh, primitive data types don't have any methods associated with them. We know that classes can have methods, and these classes over here have some interesting ones. For example, um, these are some of the constructors. So, for example, you can create an integer. The integer object can be created from an integer value, a primitive integer value. But it can also be created using or initiated using a string, for example. Maybe you picked up a string of text out of some text file, and you want to convert that into a number that you can use for making calculations. So that is a situation where these wrapper classes, the integer wrapper class over here, becomes very handy. The same is the case for example, is also the case for the double wrapper class. Again, you can initialize its value using a double um, primitive data value, or you can pass it a string to do the same thing, and we'll try that out. Um, in addition to that, classes come with a number of methods that allow you to convert from one type from their uh, from their inherent um, data type to other data types. So, for example, um, wrapper classes like I said, that are subclasses of the abstract number class contain methods called double value, float value, int value, long value, short value, byte value. And you can call any of these methods on any of those subclasses of number. So for example, you could call the double value on a float object. You can call the int value on a double object. So you can convert from one data type to another. Um, in addition to that, of course, we have a toString method that is implemented by all of these classes. Um, there's also a compare_to method, which allows you to compare one object of any of these classes with another, as long as it implements the comparable interface. So here's another view, a more detailed view of these classes and um, the methods that they come with. So here, for example, the number class, as you can see, it has a byte value method, short value method, and then it has abstract method, int value, long value, float value, double value. Uh, these are abstract because they're implemented differently in each of the subclasses. And here we're showing only the integer and double subclass because we don't have enough space if we want to look at all of the methods that these classes come with. The comparable interface contains this method compare_to, which allows you to compare different classes, different objects of these number subclasses, or actually any class that implements the comparable interface, which again are all subclasses of number plus the character class. Okay. All right. In addition to that, let me show you over here. So every um, numeric and every class related to a data type that stores a number also comes with um, uh, uh, a static two static member variables called min value and max value. Min value is the smallest possible number that an integer can store. Max value contains the largest possible number that can be stored as a value inside an integer class. Same is the case for the double class and all of the other numeric data types classes. Min value and max value, the smallest and the largest value that you can keep in there. Okay, in addition to that, we also have a value of method that I'll demonstrate. The value of method is, as you can see, it's underlined in the UML class diagram, which means it's a static method. Means in order to use it, you do not first have to create an object of this class. You can just use it directly without creating an object first. So this one inside the double class over here, you can pass it a string, and it will convert that string to a double primitive data type value. The same thing over here for integer. Value of, you pass it a string, converts it to an integer. What else? We have parse int and parse double, which take strings and basically do the same kind of conversion, but return a primitive data type. The other ones, remember, value of, return, that's a double with a capital D. They return an object of their own type, of their own classes. So, talked about a couple. We have looked at what types of. So basically, all of these guys, all of these classes can take primitive, and the constructors can take primitive data types or can take strings. Um, you can. They have static methods called value of and parse something. Parse methods that return either an object of its own class type or return uh, uh, a primitive data type. So these are the conversion methods that I just talked about. And see what else. Value of. We'll see that at work in a minute. And yes, we can also use the parse int method or the parse int method, parse long method, um, to parse double, parse float methods in order to convert from a string to, say, a binary number or a hex number, base 16. So let me jump over here and let's do a code example. So try to get through uh, example methods that demonstrate all of these. So let me begin with this. So uh, let me create a byte object and let me pass it in the constructor a string 120. Okay, and in the next line, system. Let me just, now that I have my object B for byte, um, let me print out its byte value. Okay, so I run this. There you go. So the string 120 has been converted to the number 120. We can use it for in calculations, other stuff. Okay. What else? We had short as a data type. To create an object of class short, and maybe this one. I'll pass the number 50 as a string. Just copy paste stuff. And over here, let me just print out whatever the short value of that is. 50. And let's try something else. So let's say an integer I. Let me create a new object of that. And I'm passing this one, the number 100, as an integer, just like that, not a string. It's not in double quotes. System dot line, and let me I dot, and let me print out the integer value of that, 100. You may be thinking that's very straightforward. Let me try something else now. So instead of printing out, so the integer value of I, let me print out its floating point value. So now I'm converting the integer to floating point number. Run this and 100.0. So the point 0 says that this is now a floating point number. So this is kind of accomplishing the same thing as casting. Use a floating point number. So for floating, if we use a float class, so float f, new object, and let me, in the constructor, let me pass it 100.15. And here f dot float value. minus 100.15. You can see this works pretty well. And let me just try something. We print out the integer value of 100.15. And there you go, 100. I lost the 0.15 at the end because integers do not store fractions, right? Okay, um, one last one like this. So double object and double precision floating point numbers, basically kind of the largest numbers you can store on a computer today. Um, just type in something. Line and just print out the double value of that. There you go. I'm going to e to the power 12. Okay, so it's converted this a little bit. It's fine. Let me put in a new line over here and let's move on to something different. So we just saw conversions from integer to floating point to integer. We saw how we can initiate these object values with strings or with primitive data types like this one over here, giving it an integer, this one here giving it a floating point number, this one here giving it a double precision floating point number. So that all works. Okay. Let's try out the value of methods. Double dot value of, and over here I can give it any string and it'll convert that string to a double precision floating point number like this, 99.75 as a string. Okay, and let's see what that does. There you go, 99.75 now returned to us as a double. Let's see other cool stuff you can do. Okay, so for example, let me take a string 100111010, and so I am going to take the same string. I want to convert this to an integer. So integer dot parse int. Sorry, parse int, and just copy paste this to make sure I don't make a mistake. And I want to convert that to an integer, and this string over here should be treated as a number of base 2, binary number. Okay, let's see what we get. It's the number 100, so 100111010 converted from a binary number to a decimal to an integer is the number 154. Try that out, check it manually. So just like the base 2, you can also convert to a number of base 16. So for example, the number 2a, I want to convert that to an integer. And 2a, obviously it's not a decimal number, so I'm specifying over here that this is to be treated as, it's to be read as a hexadecimal number. So if I run this, there you go, 2a becomes 42 in decimal. Okay. Let me, yeah, so that's basically all the conversions that I think that there are, right? Let's do a few more. Um, so let's go back to the integer object I that I have up there, and the integer value of that is something that I'll print out over here. So int as float, and then I'm going to print out the value as a floating point number. Okay, there you go. So 100 int as float is 100.0. So do a couple of more conversions like this. You take the floating point, the float object that I have, I print out its float value, and I convert it to, let's make that an integer, convert that to an integer. We all did that, right? Yeah. Let's try one other. So we have, we still have, we have that double object. So as a double, it's whatever it is, and I'm converting this to. Okay, so the double number was a very large number. I'll convert that to a byte, and byte is obviously too small to keep such a large number in it. So this will do something in its conversion. I'm not sure what. You could convert it to -1. I don't know what that means. But yeah. All right. And obviously that large number did not fit into a byte, which is just 8 bits. Okay. Um, in addition to that, uh, these number classes also store. Okay, it's going to be a lot of typing, I think. I'm going to do some copy pasting, I think. Um, all of these numeric data types also have min and max values that they can store, and we can look those up at any time. So byte dot min value. This will print out the minimum value that can be kept in a byte, and obviously that number is going to be uh, 127, much less than the number that we're trying to fit into it, that we're keeping in this object d double, type double. Um, just like that, I can also print out the max value that we can keep in a byte. So the min value is -128, the maximum value we can keep is +127. Okay, put a new line over here. And actually I can do the same thing for all the other data types. I can do this for data type for class short and data type short, same min. Short is 2 bytes, 16 bits. These are the highest numbers to keep in there with 16 bits. Then we have the class integer. Integers are 4 bytes. You can keep even larger and smaller numbers in there. We have type long, class long, which is 8 bytes. That can keep numbers on an even greater range in there. But these are all integers. And we have floating point numbers. 4 bytes, 4 bytes long, 32 bits. The min value over here is not the greatest or the smallest negative number. This is the smallest value above 0 that it can store. So this basically tells you what the yeah, the resolution to some extent of smallest number that it can basically keep. That's what min value shows you for float. Same thing for double. Max value still means the same thing. It'll give you the largest possible number it can store. So for a double 8 bytes, as you can see, that's 1.79 something into 10 to the power 308. So the E over here is exponent, is the power of 10, 10 to the power 308. So it's pretty big. And yeah, that's basically it for today. Um, and try these out, play around a little bit with the number conversions, and we'll see each other tomorrow.